Pleistocene Park is a large-scale ecological experiment in northern Siberia, spanning 160 square kilometers of land, gifted by the Russian government in the 1990s to Sergei Zimov and his son Nikita, who now directs the park. The Zimovs aim to restore the Mammoth steppe, a dry, grassy plain ecosystem from the end of the Pleistocene epoch, the last ice age, which ended about 12,000 years ago, characterized by lush meadows supporting megafauna, that's large animals like mammoths. This really stands in contrast to today's shrubby tundra, which are cold deserts dominated by small shrubs, trees, mosses and lichens. Those are symbiotic algae fungi organisms that replaced the steppe after the ice age. The traditional geological view attributes this shift to post-ice age warming and increased humidity, which favoured shrubs over grasses and ultimately starved the megafauna. Sergei Zimov challenges this, proposing that human overhunting with long-range weapons caused the extinction of those large animals, allowing shrubs to invade because there were no grazers left to maintain the grasslands. Interestingly, the modern Siberian climate actually mirrors the late Pleistocene, making restoration possible by reintroducing grazers. The key idea here is that without grazers, ungrazed land shifts to woody shrubs. But with grazers, their trampling and eating prevent this, promoting grass dominance. Grasslands help combat Arctic warming, which is happening about 4 times faster than the global average, by protecting permafrost. That's the permanently frozen soil covering most of Siberia. Tundra shrubs absorb more solar heat because of their low albedo, or reflectivity, which warms the soil and causes the permafrost to thaw. By contrast, grasslands reflect more sunlight thanks to their high albedo, keeping the soil cooler. In winter, grazers dig through snow to eat leftover grass, exposing the soil to cold air for deeper freezing, which reduces the spring thaw. So, grasslands plus grazers mean cooler soils, less permafrost thaw, and more carbon storage, helping to counter climate change. Reasonable herd sizes, avoid overgrazing damage, but actually enhance the steppe in several ways. Trampling breaks up tundra moss and shrubs, creating space for grasses to take hold. Selective grazing targets slow regrowing shrubs, while sparing those resilient grasses that can regrow and spread. Grazing also signals grasses to invest nutrients in their roots, building carbon-rich underground networks. And, rapid fertilization comes into play. Since the Arctic cold slows bacterial decomposition, grazers' gut microbes recycle nutrients in just 1 or 2 days through manure. The Zimovs treat the park as a kind of geoengineering project, manually clearing trees and shrubs to speed up grassland conversion, and supplementing this work with baby mammoth, a vehicle that mimics the tree ploughing of ancient mammoths. Herds then take over ongoing maintenance. Bison knock down saplings, and musk oxen digest tough tundra scrub, making way for new grass growth. The animal mix is carefully chosen to simulate an Ice Age ecosystem, including native or cold-adapted species like Yakutian horses, yaks, moose and reindeer. Non-native proxies, such as American plains, bison and Bactrian camels from Mongolia, are also introduced. Looking ahead, future plans include adding predators, wolves, cougars, even Siberian tigers, for ecological balance, plus possibly de-extinct species like cave lions or dire wolves, and ideally resurrected woolly mammoths. After about 20 years, fenced areas showed denser, more vital grass than the surrounding tundra. Continuous monitoring, of course, tracks air quality, surface temperature, greenhouse gases and permafrost thaw. In ungrazed soils, upper layers can be up to 13 degrees Celsius warmer and the thaw goes more than 40 centimeters deeper. Grazed soils, on the other hand, hold 6 times more organic carbon in their upper layers, and the benefits may deepen over time. Journalists have observed much stronger grass density coverage and vitality inside the fences compared to outside. These metrics really prove that grazers cool the soil store carbon and stabilize permafrost. Pleistocene Park has inspired similar efforts around the world. In North America, there's been a push to reintroduce bison to prairies and plains. In Patagonia National Park, native grazers are helping to restore overgrazed grasslands. In Kazakhstan, steppe revival aims to save the saiga antelopes. Rewilding, in general, highlights the crucial role animals play in shaping landscapes, often needing a bit of a human kickstart, just like the Zimov's experiment.